First, I got to introduce. So, thinking back in 2015, 2014, 2015 timeframe where the blockchain, not Bitcoin narrative was starting to first come up. And at the time, people wanted to put everything on a blockchain. There was going to be land titles and supply chains and everything else. But with a public blockchain, which was the only things that really existed at that particular point in time, it's not really possible to put everything on a blockchain. Bitcoin can handle about 3 or 4 transactions per second, Ethereum about, call it 12 transactions per second. There's a cost for every transaction, so you just can't throw everything onto a blockchain. So what we did is we started off by creating a SaaS application that allowed people to anchor data to the Bitcoin blockchain and generate a timestamp proof. And then they were able to get that information back and share it with somebody else. That way they could prove some information existed in a particular state at a particular time. And this is what the original Tierion application looked like. It is no longer alive, and I'll explain why in a little bit. But people were able to use this application, and it was very interesting. We started off, just myself and my co-founder in Connecticut. And I went to the first consensus hackathon in New York back in 2015. And we won the hackathon and sort of launched the business at the same time by creating an insurance claims processing system that created an audit trail for a claim as it went from when it was submitted to when it was processed to when it was completed. And so we were able to show back then how we were able to anchor data to Bitcoin at scale. I'm going to skip through some of this stuff because I want to have time to talk about the important things. But the key thing that we're doing is we're just taking hashes from data. We are aggregating those hashes together, which I'll go through a little bit later, publishing a Merkle root into a Bitcoin transaction, and then we're able to pull back this proof that you can pass on to other systems, and those other systems can use that to independently verify the data. The key thing here is we're not putting everything into some sort of ledger system or a registry or everything else. These are portable proofs that you can use to verify the timestamp of information. So, what we've done since this protocol that we created is called Chainpoint. It's gone through 3 major iterations now. And so what we've done is we've taken that SaaS application that you saw before, which was just something that we owned and operated, and we turned it into software that can run as part of a distributed network. So right now, there are about 8,400 Chainpoint nodes that are running around the world. And people are submitting hashes to those nodes. Those nodes are aggregating all that information, all those hashes together, and they're publishing it up to Bitcoin. Kind of like, I don't know if you guys can actually see that right there because of the resolution of the projector. But what we're doing is each node receives the hashes, and each node aggregates those hashes and submits a Merkle root back up to a set of higher servers up in the sort of architecture or the hierarchy here. And periodically, one of those is selected to generate that represents the aggregate of all of the hashes inside the system, publishes that to a Bitcoin transaction. So now what we have is essentially, we have thousands or even millions of hashes that are all part of one gigantic network, one sort of big aggregation infrastructure. So then what we do is we go back and for each individual hash that came into that system at the model, we create a Merkle inclusion that goes all the way from that first hash all the way up the Merkle tree to the Bitcoin transaction, and then goes one step further, and we're taking the hash of that, creating another Merkle inclusion proof from the Bitcoin transaction all the way up to the Bitcoin block header. So we have a set of hashes that goes all the way from the original hash all the way up to the hash that's in the Bitcoin block header. We extract all that information out, and we turn it into a list of operations that you're able to just go through, and you can go through and just get from that initial hash down to the hash that is anchored into the Bitcoin. You guys can't really see that on this projector, can you? No? Okay. I figured as much. So let me talk about a few things because I think I'm skipping over some things that are important that I was hoping these images would be able to explain. But when you submit a hash to one of these nodes, and we generate this proof. What we're doing is we're folding in trusted timestamps into the proof format, along with the commitment to Bitcoin, which is as trustless as you can get. So each node that's on the network has keeps track of NTP time, and it embeds that NTP time as a completely trusted way to just have that in there, just as a convenience function. So then what we're doing is at the first layer of aggregation, when that's communicated upstream, we're actually folding in, when you get back what's called a calendar proof, we're folding in the NIST beacon data. So NIST has a beacon service that publishes, I think it's a 512-bit random number every minute. And so now you have an attestation from the NTP time from each individual node, and then you have this attestation from the NIST beacon service. And so this is a little less trusted than the NTP time of whatever node you're communicating with, because I could say whatever you want. But we have some things built into how the network works to make sure that NTP time is within certain tolerances that we have. But we're folding in that NIST random NIST beacon data. So now you've gotten back this proof that has a set of operations that include the NIST beacon, a NTP timestamp, and then later on, we go through this entire process. It takes about 90 minutes for us to aggregate, publish a Bitcoin transaction, wait for 6 confirmations just for security purposes, and then extract that Merkle inclusion proof that goes all the way from the Bitcoin block header back down to the system. So let's talk about how people are using some of this stuff. So these are some of our current customers. Again, we've been around since 2015. And just some of the use cases that people are using this for are these are all in production, by the way. These are not use cases that are just some prototype somewhere. Xero is a company that's kind of like QuickBooks, or Intuit, I should say. They make accounting software. It's really good. I used it for like 4 years with my last company. I love Xero. They're using Tierion to prove the timestamp and integrity of data that is submitted as part of accounting transactions. And this is part of something that's optional inside their service. It's not available just by default. A company called Liaison, they aggregate healthcare data from lots of from their customers, put it into like a gigantic data center and provide analytics on that data. And they wanted to be able to provide a way to have portable data integrity proof so that when people take out that data, they send it somewhere else. When somebody analyzes that data, it has a way to verify the integrity and timestamp of when that information came into the system. Dell has a product called Boomi. It is kind of like what Liaison has. It pulls together information and allows you to do things. It's almost like Zapier. You guys familiar with Zapier? Zapier allows you to collect data and have actions that send data from one system to another using hooks and other types of services. Everything is an IoT data collection company, and Ultimus does business process management software. They're using Chainpoint to be able to create an audit trail for the, among other things, many different processes, but they started off with car loans. So if you get an auto loan, all the information about who you are, the documents, the approval process for that auto loan, everything with the bank is pushed through the system, and a Chainpoint proof is created at each individual step along the process.
Sorry, one question. Is that done after the whole loan closes or each step in the process?
At each step of the process, as I understand it, at each step of the process. So let me think about this for a second. When the process begins, they generate a Chainpoint proof at the beginning of the process to say this, along with all the other data, is the initial state of when this came in. And then at each part of the workflow, because they have a business process management application, they are creating essentially, internally, I believe they're creating like a hash linked list of all of the, I don't know exactly the data structure underneath, but think of like a hash linked list of all of the states of that transition. Additionally, if there's an attachment like an image of a check or something like that, they're creating a Chainpoint proof for all that information. So in that world, what they're able to do is they don't need something like Hyperledger Fabric. They already have an existing software application. They're not going to go back and rebuild it on something new, but they want to add this independent proof and verification capability, and we made it very easy for them to do that. And that's typical of the kind of use case that we see with a customer. Philips was actually our first big customer. In 2015, rather, they started using Tierion for a whole multitude of use cases inside the company. The first one was collecting data from industrial medical equipment like MRI machines to be able to create an audit trail of its maintenance, usage, and calibration history. And this was at the proof of concept stage, and it was a very long time ago in blockchain years. We went forward with a couple of different other projects with them. We did a system that was creating an audit trail to track how flu vaccines were disseminated, and they created a system where they communicated out information. They collected information from doctors about patients that need flu vaccines. They communicated that information out to the patients. They said, basically, here's a free coupon for you to be able to, get a free flu vaccine. And then when that coupon was redeemed, they were tracking the information. So they were tracking everything at every single step, what information went out, and they wanted to improve the integrity and timestamp of when all these events were collected throughout the system. And we did some other work in creating verifiable medical records, which ultimately they sort of moved past that. I think a lot of people have a lot of ideas about how blockchain can be used in the healthcare space, especially with medical record systems. But if you look at the way that things work, things like the large systems that hospitals buy to be able to manage these medical records, they're huge. And they are multi-year purchases with a long rollout. My wife is a nurse, and before we moved to California, she worked in a hospital, Hartford Hospital in Connecticut. They had just purchased a new EHR system, and the rollout time frame they had was 36 months long. Like, nothing is going to derail that freight train. So there may be some minor advances around the edges. We have some customers who are using Tierion or Chainpoint rather, to collect data for medical trials, so clinical trial data, to improve the integrity and timestamp of the data collection and the archive. And we've had some interesting luck with hackathons, and including launching the company at a hackathon. The distributed health hackathon in Nashville, 13 of the 18 teams used Chainpoint. Every single winner used Chainpoint. At the Consensus Hackathon, people did a food supply chain application where they were able to use Chainpoint to create a proof. And in some cases there, they used Hyperledger. Now, I'm not an expert on Hyperledger Fabric, but what they were doing is they were creating a proof, a Chainpoint proof at the beginning of all of the data that was going into their application, and then they were also checkpointing the state of the Hyperledger application periodically so that they had a proof that this information was anchored to Bitcoin. The value there is that people can't, so first of all, you can have independent proof, timestamp proof of the data that's being fed into the system. And the other part interesting was that by checkpointing using Chainpoint, a Fabric application, you would be able to prevent people from colluding and going back and editing things, anything before that checkpoint, without taking over Bitcoin, which was pretty interesting. So it was very easy. It wasn't something that we put out there. It was just something that people picked up. I think 4 teams did this. Every team that placed used a combination of Hyperledger Fabric and Chainpoint. So it was pretty neat. So the real advantage to what we're doing is that companies who have existing software applications, they're not going to rebuild everything on a blockchain. They're not going to go and reinvent all their applications. So there's some greenfield things that are out there. There's some things you can complement. But if you have an existing application and your use case is proving something, so not transferring value, not creating a digital asset, just simple proof. And you'd be surprised at the cost and complexity of trust and proving things is inside businesses. So the people at the companies, they can stay in control of their data. There's a lot of concern about putting things onto a blockchain where you are sharing information with sometimes untrusted parties. Even trusted parties, like in the last talk we had here, you don't want your competitors or your partners knowing the transaction volume that you have or all of the information. And these proofs that we create, Chainpoint proofs, can be shared. So we're hiring, so we can talk afterwards, but I wanted to leave a lot of questions that I can talk. Since I didn't have the diagrams that worked up here, I can talk a little bit more about how the technology works behind the scenes, if that's something that everybody's interested in.
can you talk about the timestamps?
Yeah.
And, they do getting it from a third party, it's portable. That's what you've done to make sure that timestamps are doing that.
Got it. Okay. So, first of all, let's talk about timestamping, and let's talk about what you can and can't prove. We like to say you can notarize your lives, which is actually sometimes useful. So just because you timestamp something or you have a data integrity proof doesn't mean that it's actually true. It doesn't attribute ownership, it's just time and state, which is useful. Now, man, that really is useless, isn't it? That's not useful. Okay. I'm going to try to do my best with one hand to talk about this because I got to keep the mic up here. All right. So you can take the way that chain point works is you start off by taking a hash of some data. I'm assuming everybody here in the room today knows what that hash of data is. You can take any information, you get a digest, fixed integer length. All right. Okay. So you start with the hash of the data. You submit that hash to one of the nodes that is part of this network. Now, the nodes receive the hash and they return back to you a hash ID, which is just a handle to go ahead and retrieve your proof at a later point. Those nodes take all those hashes and they aggregate them. Right now, they aggregate them on a 5-second interval. Each node will take those aggregate them, and they construct a Merkle tree out of those. It communicates that Merkle tree up to what's called a calendar server. Those servers are able to so basically you're aggregating things, you're publishing up to the server, and now you're able to get back a partial proof that includes an anchor not just to Bitcoin, but also, not just to the calendar, but it also includes the NTP timestamp and the NIST data that we're bringing into the system. So now you have this proof, and it has a little bit of outside information with the NIST beacon and the nodes, but it's still not that useful to you because we're just talking an intermediate step. These servers, these core servers all at the top that are running the calendar, one of them is chosen periodically to take a set of those calendar entries, those blocks that are put into there, and it aggregates them, gets a root, publishes a Bitcoin transaction. So now we have a commitment to the Bitcoin blockchain because we're including it in an op return field. And then we're getting back, we're waiting for 6 confirmations, and we're getting back a Merkle inclusion proof from the Bitcoin block header, back to the Bitcoin transaction, and all that information is sent downstream, and it's appended into a proof that looks something like what's up on the screen, except for it's legible. Typical proof will have a size of about 1, depending on the volume of hashes that are coming into the system. So more hashes means basically more levels of this whole Merkleized data structure that's coming in. So again, Ken, back to your question, you can't do anything to be able to prove that the hash of the information is accurate, but what you can do is you can take the initial hash and you can replay all the operations that are part of the proof to be able to go from that initial hash to any particular level, including the anchor out to the calendar and the anchor out to Bitcoin. So you can verify that all of those things play out and you get the expected value that you see that's published in a Bitcoin transaction.
You work with NIST, with the NIST beacon.
Yep.
I think there's some elements you have to do in terms of making sure you're getting the right beacon.
I'm not actually that familiar with how, so we've written a library that takes in the NIST beacon data, and I believe that they have a bunch of different servers that are running around the world that run this service. We grab the value from the servers, we check the signature, I believe, and just accept that particular value. Each NIST beacon service also has a hash link data structure of all of it. It's just a list of all of the values that have been published. So you can actually go back and check and make sure that the value is accurate. They just released version 2 of their service a couple of days ago. But Glenn's basically been working with them for about a year and a half now. And that provides an outside trusted level of attestation or proof for a particular timestamp. The thing that's interesting is that this NIST beacon service is run because of the government wants it. But they can shut it off at any particular time. And the thing that's different about Bitcoin is that Bitcoin has an economic incentive for that data to persist. You know, there's thousands of computers that are all over the world that have a full copy of the blockchain. To verify proof, you'll need a copy of the headers. You don't need the whole blockchain itself. But, you know, when we first started building this in 2015, it was a little bit simpler than it is right now. And there really wasn't that strong of a guarantee that Bitcoin was going to survive. The price went from $1,300 down to about $198, right around the time where we were building all of this initially anyways. And, at the time we thought, well, there are all these things that you can do with that people are trying to do. They're trying to do colored coins and other digital assets and other alternative chains. What if we just try to do something that's really simple? Why don't we just create something that's simple, that has a lot of utility, that businesses can adopt without having to reinvent their entire infrastructure? And that's kind of how we got started going down this path. And one more thing, and then this gentleman here.
Why would I want to do it, couldn't do it on my own, say, doing some certificates or degrees at a university or some training? Why wouldn't I just say I can actually fit it myself? Why are you guys? Well,
it's expensive. So each one of the nodes on our network is pretty performant. And we're doing some changes right now. We're moving from an older database to a new database called RocksDB, which is very fast. We're seeing, even with very, very inexpensive hardware, being able to create tens, even hundreds of millions of proofs per day with a node. So number one is that if you want to publish something into Bitcoin, let's say, you're constricted to about 3 transactions per second. So you can hash whatever data you want and use a variety of techniques to commit that data to a transaction, the most popular being just to hit not return. But you're going to run into scalability issues. Secondly, there's cost. So a Bitcoin transaction, when we first started doing this, Bitcoin transactions were like 1 to 3 cents. Then, over time, they went up to a couple bucks. Last fall, they went up to about $40 for a period of time. So there's an expensive. We spent hundreds of thousands of dollars last year just publishing Bitcoin transactions because we used to be publishing every 10 minutes back in 2015. Then we found, obviously, Bitcoin block time, time precision is about plus or minus 2 hours. So we have this intermediate tool that allows you to get a little bit of time precision with the trusted timestamps, the NIST beacon, and the calendar proofs. So now we publish every hour. But even still, it's a tremendous amount of money. So you wouldn't want to do it yourself. If you take, this software is all open source, you can either run a node and handle some of the functions yourself if you have high scalability needs. There's also just some libraries you can grab, and there's a discovery service that those libraries use. They will just look out to the network, find a handful of nodes, return a list to you. You submit a proof to the library, and the library will go out and submit it to 3 nodes in case one of them goes down. And then you'll be able to just use the operations to upgrade the proof over time. It takes about 90 minutes to generate a full proof. So, gentleman here in the front row, you had a question. So.
Yeah, I'm just curious, is there anything about your architecture that would prevent you from publishing to other chains, or is it just that you just did blockchain?
So we actually, so Chainpoint's gone through 3 iterations. There was version 1 came out in 2015, version 2 came out in 2016, and version 3, which is the most recent version, came out in 2017. Some of our Chainpoint version 2 actually has libraries that you get off of GitHub that include anchoring into Ethereum. This was actually right around the time of the Ethereum Classic fork, which we actually delayed. We were in that first application that I showed you, that's like the blue and the purple screen. We were actually about to implement anchoring into Ethereum. Nobody really asks for it, but we were like, well, why not? We can do it, so we did it. And then the whole DAO thing happened, and everything went to hell in a handbasket. So nope. But the open source tools to anchor into Ethereum are there. There's a couple complications. You could anchor into Ethereum. In theory, you could make a modification of what we have that anchors into like a Hyperledger Fabric. You know, I remember I think I was at a consensus 2 years ago, and IBM had a big billboard that said, "Who will you trust with your trust network?" And I kind of laughed because, you know, it's kind of like the opposite of the ethos at the time. But I think it's entirely reasonable. If you have If you wanted to, you could run, and I actually talked with John Walpert from IBM about this when he was there, set up a network of fabric nodes and create chain points that are actually anchoring into those nodes. In that case, I don't know exactly why you would want to do that. I mean, you would become the trusted party, you would become a trust anchor for all of these proofs. Why do that when you have these public blockchains? There's maybe some value in it, but I'm not sure what it would be.
Well, for all of the value of the permission ledger in terms of speed, in terms of confidentiality amongst the nodes themselves, even the traffic patterns and if the data is encrypted, but being able to fence post on a regular basis into the public ledger allows you at least not have to worry about the fact that, hey, you only have 5 nodes and they can collude. They, you know, if they're anchoring in the public ledger, then you can't change the past.
Exactly. So
Might
that's
otherwise be possible in a small way.
yeah, that's the main use case that we see. And you know, it was interesting because so Microsoft's been a partner of ours for a while now. We've done a couple projects with them. And at the last consensus, they actually surprised us. They announced a product called Microsoft Workbench, which is a way for you to create a private blockchain application on their system. And they were very eager. They said that they had built it. They showed us a prototype and they announced it on stage. They had built this thing that was anchoring into Bitcoin for exactly the same, using Chainpoint, using the same use case. Kaleido, which was a product from Consensus, was doing the same thing, but into Ethereum. So being able to have these timestamp proofs that anchor your state of your application into a public blockchain, I think over time is just going to become a standard feature. You're just going to be expected because it provides you a very inexpensive, high security guarantee. And then all the information that's inside that chain, like let's say you take a set of records from inside of your application and you want to send it to somebody else. And that somebody else doesn't need to know who you are necessarily, or they want to have an integration back into your system to verify the validity of it. If they want to be able to check like the identity, they could use something like Indy in some future scenario where there's an identity out there. And maybe the digital signature on that record also contains a timestamp. And you're able to check that information as well without actually having to look at your application. I think that's the kind of future that we're moving towards. But the infrastructure just isn't there yet. I mean, obviously it's still really, really early days, but you know, to Brian's point, that was a good application of this kind of technology. Sure.
And when you unwind the product that you have, when you unwind it, is there any specific information about the values of that transaction, or is it just
None.
okay?
It's just a hash. So all you're seeing is that there is a hash that to the public, all you're seeing is that there's a hash that's published in an opportunity in a Bitcoin transaction. There's other ways to do it, but that's the way that we do it today until a couple other things
So
happen.
that just means something in my personal context, in my system.
It actually wouldn't mean anything. Think of it this way, there could be 50,000 people all using Chainpoint at once, each sending hashes into the system to generate proofs. Now, each one of those individual hashes means nothing to us, but it means something to them. They all get aggregated together through this whole structure that we've talked about, and it ends up with a root value that gets anchored into Bitcoin. That root value that's anchored into Bitcoin is the only thing that's actually revealed to the public in any of this. And so that has no relevance to anything that's downstream, and so there's no leakage of information. I've seen some people say that these things are zero knowledge proofs. I think it's a bit of a stretch. Yes, absolutely. But yeah, they're not. They're not. But I've heard people talk about these kinds of proofs of proof of existence stuff as being zero knowledge because it has no information that's the root.
So that hash that I submit to Chainpoint, I have to keep a copy of that.
You have to keep a copy of the proof. And furthermore, it's even more subtle than that. People just tend to think that you can just hash anything and just like do this, and then you can hang on to whatever you have. But you need to make sure that whatever you have is stored in a format that is, you can serialize the data or do something to it to replicate that hash. So for example, if you have a PDF that's on a file system of a MacBook, and you hash that PDF and you generate this proof, and then you send it to somebody else and they open it up on a Windows machine or whatever, sometimes different file systems add padding to the files themselves, or they do other things that can change. Yeah, they can change the value for that particular file. So, that's something that we've experienced before in the past, where just like sending things around is that sometimes stuff gets added onto it or changed such that like the meta information for the files.
Was it record last open or something like that? STP?
I can't say specifically what it is, but I know if you email things, you can have problems. If you move things between computers, you can have problems. So people who archive data, especially files, have to take care to make sure that however it's being stored and however it's being archived can be done in a way that minimizes the risk of that. And it's not necessarily so much with like binary files, but with other types of messages or something else.
Web pages with tracking beacons and then.
Well, I mean, anybody who does anything with a web page, that a web page is a freaking mess on the inside. Sean, right here?
So how do you share those proofs? So let's say I submit my hash, it's anchored to the blockchain, and then I want to go to a third party and say, no, I submitted it at this point. Is there something I can give them so that they can grab that and run it themselves to do verification?
Yes. There's an open source tool that you can use. There's an open source library that you can use to build something yourself. We also have a React application that basically gives you a drag and drop interface. So you can take the proof and you can drag it onto this application. You can also, inside that same React application, you're able to type a string of text or drag and drop a file onto it or give it a hash itself, and it will generate that proof. And it's not quite out yet. We've gone through a bunch of iterations on it. We're trying to make sure that it can be very easily embedded inside a web page or inside a mobile application with minimal modifications. So we've always had, originally there was a web page at Tierion.com/proof, and where you could do this drag and drop thing. This is going back to 2015, and then Tierion.com/verify. So that's interesting because it gives people a way to do things visually, but ultimately we're kind of a trusted party for being able to verify that. So then we released some open source libraries where people can make things themselves, which a lot of people have. And now we're making it so that this is very usable by any user, or giving a tool that some of our customers, like Ultimus, for example, inside their application, they have different check marks and different things that represent the flow of a process. But they wanted something that was embeddable inside their application that people can use to verify these proofs. And they wanted to make sure that it could be available on their website. So it's a strong use case of how that technology is usable.
And you said those proofs are like 1 to 2K?
Yeah, depending on the volume of proofs that's coming into the system, typically 1 to 2K. Gentleman right there?
So you mentioned there are thousands of nodes for running the checkpoint, right? So what's the incentive for this app node for checkpoint nodes?
I'm sorry, can you repeat the question?
What's the incentive for this app checkpoint node?
Got it, okay. So right now, if you run a chain point node, the nodes get audited every 30 minutes. So we're checking information about whether you have a full copy of the calendar, NTP time, all these other factors. And those nodes are rewarded a certain amount of token for going through that particular process. So that's the incentive for people to run the nodes. Now, in addition, so just like with Bitcoin, there's a fixed subsidy that kind of goes out a little bit over time. But on the other end of the spectrum, there are people who are paying that token into a service to be able to submit hashes, archive proofs, things like that. We have a mechanism for collecting that information. And eventually, we'll get to the point soon, hopefully, where that is recycling back to the users to create kind of a closed loop economy. So there is a reward mechanism on a fixed subsidy and sort of like transaction fees for node operators. And there is a cost to be able to generate and store a proof. So something that's interesting is that people sometimes ask, well, why don't you just get people to pay in Bitcoin? Well, there's the transaction fees alone were something that we were trying to minimize against when we were trying to take this from being a centralized application being something to operate as part of a distributed network. So you got transaction fees and you've got throughput. Now ultimately, to run something like this, you need to be able to have a token. So if you're anchoring in Bitcoin, you're spending Bitcoin periodically. If you're publishing an Ethereum transaction, you got to spend some Ethereum. So the function of the token does a couple things, but it acts as like a digital commodity. It says basically, I have a claim on a fraction of whatever these anchoring fees are to be able to publish that. So I don't have to, as a business, I don't have to hold Bitcoin, I don't have to hold Ethereum, I don't have to hold all these other things. That is a pain. It's important to note that the people who are running nodes are oftentimes not the businesses themselves. Sometimes they're outside service providers. So in the case of like Philips actually ran the first Chainpoint node forever ago, and they wanted something. They were like, "Well, you're a small company. You guys just got your seed round, but we don't want to depend on you forever. We want to be able to have something that runs inside our infrastructure that can survive." And to be honest, that was really kind of the genesis for moving in that particular direction. So the key thing that's different, you have people who are running the software themselves. The software has some utility for them. So if they're running private nodes, they just want the service the same way that you might run a mail server.
If I wanted to buy a portfolio of auto loans, could I get a certificate, issue a proof certificate for each of the loans when I bought the portfolio?
Okay, so you might be able to do that, and our Chainpoint software might be part of that solution, but not the full solution. So if you're going to buy a certificate of auto loans, you're talking about buying like a digital asset in that case. Or $100 million. Okay, so now you're going to want to know the identity of the parties that somehow prove some of the identity of the parties who are involved in those loans, which we don't provide. And you might want to have some sort of digital asset or some sort of, blockchain type thing that represents the actual loans that are in the portfolio, which we don't do. What we can do is provide you or somebody else with the ability to go back and audit that loan process that we talked about before and verify that the state of all the information that is probably being archived somewhere that's tied to those auto loans is accurate. So you would be able to prove things like this person came to this came to this application on a particular, not this person, but this information representing this person was collected on a particular day, and that these documents were there, maybe this loan officer approved this. You'd be able to track all of that and be able to verify all those steps along the way. But you wouldn't have strong cryptographic proof of their identity or many other things.
My question really is just, is your system designed so you can correlate each one of those audit trails back to a unique loan ID number?
You would have to rely on the person who architected the application to correlate that back.
And for this to really work, it has to be done at the time of the process. You couldn't retroactively go back and,
That's the point.
right.
Yeah, you're right. Yeah, you can't go back and recreate these at some other point in time.
So people, users of your system, rely on your auditing of third-party Chainpoint servers for a guarantee that the system is working correctly, right?
Well, there is a little bit of trust in the middle in that process between when the network receives a hash and when a transaction is published. But there's some sort of checkpoints along the way, so they could check the NIST beacon information after they get something back and see this match a recent value that's been published in the last few minutes. If they really wanted to. And then each individual proof is self-contained. It doesn't really have any. It does have references to outside sources, like a Bitcoin transaction contains this op return value. But ultimately, you're able to verify the proof without any reliance on us at all. There isn't, I don't think that there is a way, there's always a trade-off between decentralization and performance and scalability. And in this particular case, it's not like when you submit a hash, you're giving somebody your money, or you're giving them some valuable asset or information. There's a little bit of trust in that time period, but once you've got that final proof back, you're good to go. You never have to, rely on us ever again to be able to verify that proof. Any questions?
So do you offer this as a software as a service, a certain price per proof?
So let me kind of go back and explain this. So this doesn't look very nice up here, but this is what the original Tierion application looked like. So kind of a funny story. I decided to get rid of my old company, sell off parts of it, and start building Tierion the same week that my wife told me that she was pregnant. So I had a 9-month deadline to finish making those. So I would stay up every night till like 1, 2 o'clock in the morning, which she of course loved. We built this, and after that consensus hackathon, we started getting lots and lots of signups. People were signing up like crazy. We were getting like 30, 40, 50 signups a day for some long period of time. It was originally a SaaS application. There was a fee for usage of the system. There was what's called a hash API, which allowed you just to send us a hash. There's also something called a data API. You could actually send us your data. We would collect the data, hash it, archive it, generate a proof. There was a link into Zapier, so you could push it out to other systems. It's pretty sweet. So when we made the decision to move from being a SaaS application to being to trying to build a centralized network or distributed network rather for doing this, we knew that we needed to make some big changes from this. So long story short, in May of this year, we shut this off right at consensus. At the same time, we announced that we acquired Proof.com, and we're building a new service around that. But so this thing that I worked so hard and I designed the whole front end for, and everything you see on the screen, every pixel, every word, every line of code was something that I made. Everything that's behind the scenes is something that my co-founder made. So yes, with tears in my eyes, we hit the button and shut it off. Ultimately, we think it's the right thing to do for the people who are operating nodes and the right thing for our business. But we are planning on building something new and different. But yeah, this is gone. All right, well, thanks for having me, everybody. I really appreciate it.
And we do have the space for just a little bit longer, so if people have any general questions about Hack Ledger, we can field 1 or 2 questions. If not, thank you everybody for coming. Were there any questions? Anybody have any? Okay. On your way out, if you could please help us clean up. If you take your chair, and you can see where Ken is in the back, where he is holding those up, we would definitely appreciate it. So thank you very much.
Hi, I'm an engineer.
It's the other way around. Yep. Okay. I just wanted like pretty good job of that. A little outrush of what we say in this, but I was asking, like, during the thing, like, I said you guys were wrong. I meant that to be a joke. People are trying to exaggerate what my standards are. Everybody use the buzzword.
upgrades and created restaurants. I don't know, I'm not on like the federal research so I don't really know, I would say better than HGX just because it's been released it tells all the way there are helps, but they're like they're doing things so that's good.
In general, for process computing on top of the hardware.
I think it's fantastic for a lot of applications. So for stuff like my personal right? You can do that in SGS. It's the overhead. There's much less risk of data breach. Someone could be able to compromise SGS chips to get like there's money in there, but there's not let's crack SGS.
Well, it depends on the cache.
Yeah, so that's what Intel is that like, if you spend $1,000 and expect you can crack one chip, if they weren't able to spend millions of dollars to put a chip, as long as like you have to do that, then they're like, okay,
A single chip is not worth
fine, you can crack one chip as long as the value that that one chip is responsible for is in CPU. Yep, it's good. So